us for our the last day of our virtual open week. So if you missed any of the sessions throughout the whole week, you can still go to our YouTube channel to sort of like be able to learn more of what we've covered throughout the whole week. So today we'll be looking at the insights of mechanical engineering. But just before we start, I wanted to just highlight a couple of things. So this session will be presented by three of some of my colleagues. Dr. Arti, who is also our course and RPL coordinator and senior lecturer, and then Dr. Arvin, who is our VET program leader and lecturer, and Dr. Milind, who is also our course coordinator and senior lecturer here at EIT. So just a couple of maybe some guidelines so you don't get any sort of like sounds or notifications when you're trying to watch the session. So just follow the instructions, just ensure that you enable all the settings. Some common questions. We get people asking about the slides and the recording. Yes, we will be sending you the recording and the slides. So we're aiming to send this out by Monday, the 21st of October. So just ensure that you look out at your emails and more especially junk or spam folder. All right. For now, then I will then hand over to our presenters and enjoy the session. Dr. Arti, I guess you can take it away.
Thank you very much, Barry. I hope everyone can hear me nice and clear.
Yes.
All right. So let me really quickly walk you through the agenda of this session. We will start with our introduction. So we'll present ourselves and then we will move on and I will present an overview of mechanical engineering. Then Dr. Arvin will take over and he will talk about mechanical engineering. Sorry, it looks slightly messed up, but then we have this pathways and courses. And later on we have agenda item on mechanical engineering remote laboratories that we have. So talking about myself, my name is Arti. I have been in academia for more than 20 years now. I have a PhD in mechanical engineering. I'm based here at Perth campus of EIT, and my research interests are mainly about condition monitoring of machine tools, prognosis and diagnosis of tool life, and smart manufacturing and automation. Over to you, Dr. Arvin.
Hello, everyone. My name is Dr. Aravin Arumugam, and I am actually also a mechanical engineering lecturer, and I'm actually the program leader for the vocational education training here at EIT. Thank you.
Okay, hello everyone. Welcome to this session for the mechanical engineering, and I'm Dr. Milind. I'm one of the course coordinator and a senior lecturer at EIT. I'm also based in Perth. I got few years of experience in academia and industries, and I did my PhD in mechanical engineering, and I'm actually looking after bachelor's, master's, and doctorate programs in a way for EIT. So that's me. Welcome all.
Thank you very much, Dr. Arvin and Dr. Milind. So as stated earlier, I will start with the overview. So good morning, good afternoon, and good evening based on whatever time zone you are currently in. And thank you for joining me today. I'm really excited to talk to you about mechanical engineering, which is one of the broadest field of engineering. Now, whether you have a technical background or you are new to this area of engineering, I hope to give you a clear picture of what mechanical engineering is all about. And we will also explore some of the exciting areas that fall under mechanical engineering branch. Now, if we talk about mechanical engineering, at its core, it is one of the oldest and broadest branches of engineering. it deals with design, analysis, and manufacturing of mechanical system. So systems that involve motion and forces, those are the systems mechanical engineers mainly deal with, while applying principles of physics, mathematics, material science, etc. to create machines and devices which make our lives easier and better. I won't be exaggerating or over exaggerating if I say that mechanical engineering touches almost every aspect of our daily lives. For example, the car you drive, or the elevator you take, or the coffee machine that you use in the morning to get your coffee done. All those products, they have some sort of mechanical engineering going in. So engineers work behind the scenes to ensure that these machines are efficient, safe, and reliable. Now here we can see the broad knowledge area. So mechanical engineers, they have a lot of knowledge in all these areas. All these areas, they sit under mechanical engineering. We need to have knowledge of mechanics, that is statics and kinetics. We also need to know a bit about thermodynamics, how the heat is generated, how heat is transferred, materials, their properties, their applications. We also need to have knowledge about manufacturing engineering, that is what different machines are and how they can be used for various different manufacturing processes. Mechanical engineers also need to have knowledge about engineering design, how they will design the parts and components so that they can withstand the given forces and stresses. They also use computer-aided design and simulation. Mechanical engineers also need to have knowledge of control systems, power and energy systems, kinematics and dynamics of machines. They also need to have some knowledge about robotics and mechatronics, heat transfer, and instrumentation and measurement. So these are some of the key knowledge areas. Now, as I already mentioned, mechanical engineering is a broad umbrella, it's a broad field, and quite a few different applications and branches sit under mechanical engineering. So we will go into a little bit of detail of all this one by one. So moving on and starting with computer-aided design. So mechanical engineers, they create detailed plans and blueprints for mechanical systems and products. Those sort of things involve selecting appropriate material, specifying dimensions, and ensuring systems functionality, etc. So in doing all those things, computer-aided design software come in really handy. They use these CAD tools to design everything from buildings to automobiles, helping them visualize the products, test the performance, and make necessary adjustments even before any physical work can get started. So that is computer-aided design. Moving on, next application is manufacturing engineering. So the manufacturing engineering is the process of turning raw material into finished products. Manufacturing engineers, they focus on how the products are made, ensuring that they are created efficiently and at very high quality. Manufacturing engineers also look for various different ways to automate and streamline the processes to save time and reduce the cost. Imagine an assembly line where robots and machines are working together to build a car. Engineers also make sure that entire process is very smooth, efficient, and it produces really high quality vehicles. So that is manufacturing engineering. And as we have been talking about cars, next application is automobile engineering. So speaking of cars, automobile engineering is a field where engineers specialize in designing, developing, and testing vehicles. This area is all about making cars safer, more efficient, environmentally friendly. And again, it's not just the cars which use fossil fuels, electric cars to advanced driver assistance systems, all those things are included as a part of mechanical engineer's job. So think about the electrical vehicle you see on the roads today. Now, behind the scenes, mechanical engineers work on the engines, they also work on the batteries and even aerodynamics. So now you should be able to see how various different key knowledge areas come into the picture. They need to select the most suitable material. They need to design them so that they can withstand the forces. Again, aerodynamics, thermodynamics, and fluid mechanics also come into the picture. So that is automobile engineering. Moving on. The next is air conditioning, or we fondly call it HVAC. HVAC stands for heating, ventilation, and air conditioning. So air conditioning engineering, it's a vital field, especially in our modern world where temperature control is very crucial for both comfort as well as for some of the industries where they need to maintain a certain temperature. So engineers design these HVAC systems to regulate temperature, humidity, and air quality inside the homes, inside the offices, even inside the industrial plants. So when you walk into a cool building on a hot summer day, or when you walk into a warm building in a cold winter day, thank the engineers who designed the system that keeps you comfortable. Yeah, so that is air conditioning and HVAC. Moving on, materials. Now, materials are everywhere. And as engineers, when we start thinking about new products, we also need to start thinking about materials simultaneously. What sort of material are we going to use? And again, sustainability is another aspect now being added to material selection. So engineers have started about entire life cycle analysis, or if you like to call it, it's a cradle to grave entire cycle, starting from getting the raw material all the way to processing, converting that into the product, and all the way to disposal of that product. So material engineering is where mechanical engineers work with various different types of materials. Those materials could be metals, they could be plastics, composites. Every day, new and new materials are being invented. They are coming up with quite a few new materials every day. So material engineers, they focus on choosing the right material to create strong, durable, and efficient products, whether it's for the buildings, it's for the vehicles, or even for the electronics. Everything requires material, and then all the engineers need to think about the properties of material. What properties are needed in order to make into a successful product? So imagine building a bike. Engineers choose materials that are lightweight, but again, strong enough to handle the rider's weight and the bumps on the road. So that is an example, simple example of material selection. Okay, next one we have is power plant engineering. So power plant engineering focuses on generating energy. Now you might think that power plants is more about generating electricity, and what do the mechanical engineers do here? So it's all mechanical engineering at the back end, right? Whether it's a steam turbine, whether it's a normal turbine in a hydropower plant, it's all mechanical equipment. So power plant engineering, energy is there, and engineers in this field, they design and they operate the power plants, whether the power plants are running on fossil fuels, nuclear power, or renewable energy like wind or solar. Now, this engineers' work ensures that we have the electricity we need to power our cities and home. So back end is more or less mechanical. Next is mechatronics and robotics engineering. So this is a blend of mechanical engineering, electronics engineering, and computer science. Engineers in this field, they design robots and automated systems used in manufacturing, healthcare, and even exploration. So robotic vacuum cleaners, you can consider them as a very good example of what mechatronics engineers create. They design the machines that can do tasks which are too receptive or which are at times too dangerous for the humans to do. And that's where robots and automated machines come to the rescue. All right, next one we have is agricultural engineering. Now you might think agricultural engineering has a lot to do with the plants and crops, right? How would mechanical engineers will play any role in this field? Let me tell you, agricultural engineering is an important area where mechanical engineers can work on improving farming equipment. Now, I'll give you an example of Australia. Australia has vast farming lands, but a very less number of manpower. And that's where a lot of automation is required, where just a single person can handle so many different processes, which will otherwise require a huge man force. So that's where mechanical engineers can come into the play. They can help improve farming equipment, irrigation system, and even the food processing industry. Mechanical engineers can definitely help a lot with bringing in more efficiency. Mechanical engineers can develop technologies to increase food production while reducing labor and environmental effect. So that is agricultural engineering. The next one we have is mining engineering. It's quite distinct in its focus on the mining and extraction of minerals and resources. It's not exactly mechanical engineering, but it definitely shares fundamental principles with mechanical engineering. Mining engineering covers design and operation of mechanical systems which are used in mining. So drilling rigs, crushers, conveyors, material handling equipment, all those equipment that you see, they all have mechanical engineers behind them. Whether it's about designing those equipment, improving their efficiency, or operating those instruments, it's always mechanical engineering. So my mechanical engineers, they design and manage equipment used in extracting minerals and resources from the earth. Main focus here would be making this mining processes safer, more efficient, and less harmful to the environment. Next one we have is oil and gas engineering. So oil and gas engineering involves designing systems to extract and transport oil and gas. Mechanical engineers in this field, they ensure that pipelines, drilling rigs, offshore platforms, number of pumps, oil and gas rigs, they use number of pumps and compressors. So all those equipment and even refineries, they operate smoothly and safely. And at the same time, they also focus on minimizing environmental impact. So that is the key there. All right, next one we have is marine engineering. So marine engineering is the field where mechanical engineers work on the design and maintenance of ships, submarines, and other offshore platforms. Now here, mechanical engineers, obviously, they would ensure that those vessels and structures, they are seaworthy, they are efficient, and they are environmentally responsible as well. We don't want to pollute the oceans where those vessels go into. So that is marine engineering. Last one we have is aerospace engineering. So it's a field where engineers design and build aircrafts and spacecrafts. Now they focus on making planes safer, faster, and more fuel efficient, while also working on spacecrafts that can explore beyond Earth. So again, this is such a field where a lot of key knowledge areas, you can see they will come into the play. Aerodynamics, fluid mechanics, thermodynamics, material selection, design, all those things will come into the play when designing a highly efficient aircraft or a highly efficient spacecraft. Spacecraft, I would say it's more challenging because just imagine you're sending something onto the Mars, you don't know what the environment will look like over there, what would be the temperatures, pressures, etc. You can just imagine and simulate it here, but when it goes into the real environment, the final outcome might be totally different. So that's application of mechanical engineering into the aerospace side of things. And with that, I would hand it over to Dr. Arvin.
All right. Thanks, Dr. Arti. I'm just going to check whether my slides are moving. Okay, great. All right. So first of all, I would like to welcome everyone for this presentation, and obviously taking on this session from Dr. Arti. What I'm going to look into now is I'm going to quickly say a few things regarding the potential job areas where mechanical engineers might work, and probably will spend a bit of time on looking into some of the emerging technologies in mechanical engineering. Right now, as Dr. Arti has actually pointed out through the various slides that she has actually gone through, you can see that the mechanical engineer's job prospect is quite wide. Right, so generally, if I put this into a more kind of summarize this scope of job when it comes to mechanical engineers, whenever we are looking into any task or any job which requires design, manufacturing, installation, testing of any sort of mechanical systems, mechanical components, mechanical structures, obviously you're looking into a mechanical engineer behind that, right? And another important thing is mechanical engineers are are widely involved with energy conversion. So if there's any system that requires an energy conversion, all right, majority of the system that Dr. Arti have mentioned involves conversion of energy from electrical to mechanical, mechanical, chemical. Okay, there has to be some sort of conversion of energy. And this is where you require mechanical engineers, right? So, and you can see the list there. It's a quite long list that simply says that you've got a huge prospect when you become a mechanical engineer. All right, saying all of that, let me just go into a bit of this emerging technologies. I just before moving on, is the slide looking fine for everyone? Because the slides are really looking quite small for me. I'm kind of stressing my eyes to look at it. Is there somewhere I can, as long as it's fine for everyone, it's fine. Okay, because it looks a bit small for me. Great, thanks a lot. Whoever did that. All right. Okay, coming back to what I was just saying, just going to talk about, just going to put in some thoughts into these emerging trends that we have in mechanical engineering. Computer aided design and computer aided manufacturing, Dr. Arti pointed out that a while ago. Might just want to elaborate on that a bit. Design and manufacturing. Now, these are the two important tasks mechanical engineers will do, right? Every mechanical engineer might be doing some sort of design, some sort of manufacturing as part of her or his work. But when you incorporate this with computers, we do have computer-aided design and computer-aided manufacturing. And Dr. Arti mentioned something about CAD a while ago, but I will just mention that back again. Computer-aided design typically looks into the use of software in order to create digitally 2 or 3 dimensional design models or even simulations, right? Now, the softwares have obviously helped a lot in terms of doing rapid, fast, and efficient adjustment to the design, modification to the design, and so on, before the design can be finalized and sent to manufacturing, right? So that is the CAD. I'll point out a bit on the CAD software later on, but let me just bring in CAM, because CAD and CAM together, they are like twins. Okay, we call them CAD CAM nowadays. They come together, right? So computer-aided manufacturing generally involves the use of software in order to control machine tools, generally via creation of CNC programming and codes. The drawing from the CAD will be sent to a software, any sort of CAM software, and it will convert it into an instruction, a code, and that will be turned later on input into a machine like a milling machine or lathe machine, and then you'll be able to manufacture the part. So CAD and CAM. And typical software that you'll see, I'm sure some of you might have used, surely most of you might have heard. Under Autodesk, we have got AutoCAD, we've got Inventor, SolidWorks, we got CATIA, a very advanced tool, Creo, Revit. Mechanical engineers might not use that a lot, but if you are into structural engineering and stuff like that, probably you might use Revit. And then when it comes into CAM, we got Mastercam and we've got SolidCam. So these are some of the CAM related softwares, right? Now, what's the emerging trend? Well, everyone's talking about AI at the moment, right? The use of artificial intelligence and machine learning, obviously, with integrating it with CAD softwares like this, have obviously been quite useful in terms of enhancing the design capability, automating repetitive tasks, as well as optimizing the designs, right? With these AI technologies now, we can simply analyze any sort of data, create patterns, and eventually create models. So it's made a lot of flexibilities in terms of CAD. Same goes to with CAM, all right? Even in CAM, the integration of artificial intelligence and machine learning, it's kind of actually helped in terms of optimizing the tool part, okay, the way the tools have to move, reducing machining error, all right, as well as enhancing manufacturing efficiency. So quite an interesting advancement coming up there in terms of integration of AI with CAM. Might just be in the slide for a moment before I move on, yeah? And we've also got something called augmented reality, virtual reality, okay? For example, if you look into CAD, the use of CAD with AR and VR has not really come up well yet because of the high investment cost involved in it. But we do have some CAD softwares like SolidWorks e-drawing, they call it, right? It actually gives the integration of VR and AR so that the designer can typically visualize the design in a virtual reality environment. Right, so that's one thing to look into, and we have got this cloud-based solutions now with CAD and CAM together. With these cloud-based solutions, you can have designers and engineers sitting anywhere around the country, around the world, but they can collaborate seamlessly in terms of sharing of data, kind of simultaneously editing drawings, collaborating in terms of manufacturing and stuff like that. So it's quite a lot of things going on at the moment in terms of CAD and CAM. All right, what else can you look into? Let's move on. Well, 3D printing. Okay, 3D metal printing, 4D. So we got this 3D, 4D, right? Now, obviously, this comes as part of the, what they call this, generally the whole concept of sorry, what is that? Can I have a quick look into? Sorry. All right. So 3D. So what's the differences between this 3D? Is there any sort of overlapping happening on the screen?
Screen looks all good. You're on 4D printing slide, Arun.
Is it? Okay. Because it looks totally different. So can you just see the slides?
Yes, yes.
It's all
Okay,
clear.
all right. All clear? Great, superb. Okay. Now, anyway, coming back to what I was talking about, 3D, this whole thing about 3D printing. 3D printing is generally looking into creating complex structures using adding layers, material layer by layer, right? So when you talk about materials, we do have, obviously, started off with polymers, and then now we are also start looking into metals and stuff like that. So we can generally build layers of polymers and as well as metals in order to form any sort of products. So 3D printing is generally widely used. It's actually coming with another name, additive manufacturing, right? So additive manufacturing, the reason why it's called is because we're adding materials layer by layer. There's a lot of different technologies in here. We got something called powder bed fusion, stereolithography. This is very much the start of 3D printing, right? It was kind of invented in 1980s, I believe, so if I can recall the year correctly. Wet polymerization, mainly for polymers, and then we have also got the material extrusion, obviously using polymers as well as metals. And where does 4D comes? Now, 3D, 4D, the 4D bit here is this additional thing that's involved, okay? With 4D printing, we are actually using smart materials. Dr. Arti pointed out materials a while ago, okay? So we got this smart materials that are able to kind of change shapes, okay? Properties via external stimuli, for example, heat and light and electricity, all right? So various things. So with this whole idea about 4D printing is we are actually putting in the fourth dimension. The fourth dimension here is the time dimension, right? So 3D is very much static. 4D is very much something that is more dynamic in nature. For example, I'll give you a typical example. For example, if you, in plumbing systems, if these pipes are produced using 4D printing, what they can typically do is they are capable of changing their diameters in response to the change in flow rate or water demands. So that's where 4D, 3D comes in. All right, let's move on. So obviously the other part of it is computational fluid dynamics. Now this kind of falls between another big umbrella called computer-aided engineering. So we got computer-aided design, CAD, computer-aided manufacturing, CAM. So prototyping was in between those two. But prototyping used to be done in the olden days for testing purposes. But nowadays, hardly we use prototypes for testing anymore because we have got this FEA type softwares that can do all this testing. One of it is this computational fluid dynamics. So computational fluid dynamics is very much a software that kind of uses computers to predict liquid gas flow using an equation. I hate that particular equation. It's called Navier-Stokes equation. I don't know how anyone has heard of it or not. That totally out of the thing. It kind of relates the conversion of mass, momentum, energy, and so on. So the CFD simulation generally allows a designer to analyze the flow of air, flow of gas in order so that they can optimize the design. Widely used in aircrafts, automotive design. And another important thing is, as I mentioned, the integration of AI is also coming into CFDs. Because now with AI, these CFD models can be trained with historical data so that if you are developing another design using historical data, the AI is able to change the mesh, change the input, output, and so on, so you can optimize the design faster. So that's, again, AI and machine learning is coming into CFD. All right, what else? Just looking at the time also while I'm talking. So the electrical vehicles. Now, where does, like how Dr. Arti was saying, where mechanical engineers comes in plant thing. Obviously, mechanical engineers comes a lot in electrical vehicles because, as I said, mechanical engineers goes into anywhere where you need transfer of energy. In EVs, you are talking about transfer of energy from electrical to mechanical and vice versa, right? So mechanical engineers are obviously looking into design of vehicles, as in they're designing the structures, the chassis, the suspension, the brakes. They are in fact designing, optimizing the powertrain that is involved in this EVs. So that is where we have mechanical engineers back again. Nanotechnology, another thing. Obviously, Dr. Arti pointed that out also, right? So we have got materials engineering is a big field of study in mechanical engineering. So we have got these 4 engineering materials so far: metals, polymers, ceramics, and composites. But on top of that, we have got additional materials that are being built, that is being kind of invented, engineered, I would say, engineered, okay, so that we can incorporate it into nanotechnologies, because we are already building components, parts that are quite small in size, in nano form, and we need materials for those kind of things. So nanotechnology, biomechatronics, okay, something that was pointed out earlier. This was, in fact, a term that was coined by the Japanese, right? So mechatronics, mechanical and electronics, but now we are, in fact, putting both of these together into biology. So we are looking into prosthetic arms, design of prosthetic arms, pacemakers. So this requires a mechanical engineer, this requires an electrical engineer, as well as we got another breed of engineers who are called the biomedical engineers. They all have to combine together to look into biomechatronics, right? Well, before me finishing off, let's talk about the Industry 4.0. Now, the Industry 4.0, that is part of the industrial revolution that we are in at the moment. Going from Industry 1.0, 2.0, 3.0, 4.0, what's happening in here is we are going through an advancement in technology, right? So Industry 4.0 uses something called the industrial Internet of Things, kind of collaborating 4 things: connectivity with data and stuff like that, analytical and intelligence. That's why you got artificial intelligence coming in. Human interaction with machines. That is where you got virtual reality, augmented reality, and as well as advanced manufacturing. That is where additive manufacturing, renewable energy, nanotechnology, all this. So we have actually joined all of this in Industry 4.0. In fact, while I'm talking to you, we have actually gone into Industry 5.0, right? Industry 5.0 started in 2020, where we are talking about this collaboration between humans and robots. We are actually in Industry 5.0 instead of 4.0, actually. All right. saying all of that, let me just finish this off with a slide thing. There's some slight new technologies also we need to mention. The digital twin. The digital twin is in a way taking over the prototypes, right? So now we've got the digital twin, which is digitally formed, and that will tell you exactly how the actual product will look like. The input and output from the digital twin and how the digital twin is responding to it can be used to change the actual system in terms of design wise and operation wise and so on. And then we've got this integration of data, something that was mentioned by Dr. Arti earlier, I think so, how these various product data can be merged together seamlessly. We got the PDM, as well as finishing off with the PLM, with the product life management. These are all very much software based. So to finish up what I was just going to say, where do we what's the future for mechanical engineers? Future for mechanical engineers is quite bright, right? It's very bright. So there's a lot of things yet to be done. That we need to obviously make the transportation things a bit more perfect. We saw SpaceX Starship this week, right? Last week, I think. Okay, so the vertical landing and stuff like that. A lot of things needs to be talked about there. Robotics, a lot of work needs to be done on that. Okay, machines for harnessing energy, renewable energy. A lot of things needs to be mentioned on that, right? So with all of that, I would say that this particular field of engineering, mechanical engineering, obviously promises a lot of opportunities as well as prospects. So with that, I'll just want to finish this off, and thanks for listening to what I was going through. With that, I'm going to kind of send this session to Dr. Milind to finish it off. Thank you.
Thank you very much, Dr. Aravin. Excellent presentations from Dr. Arti and Dr. Aravin. And now I'm taking the control over this. So give me a second. Okay, so I'm going to actually talk about what are the mechanical engineering courses which you can probably pursue with EIT. So let me go through some of the courses, and this courses, just give me a sec. I just need to make this bigger. Okay, so first of all, before I start talking about the different courses we have at EIT, let me talk about the engineering pathways we have available at EIT. So anyone with the trade or technical qualification who are already working as a technician, for example, in the industry, can actually take advanced diploma. If they have 2+ years of experience, they can take advanced diploma in mechanical engineering. And then there is a pathway to go for bachelor's undergraduate certificate or a bachelor's degree, or they can go to a graduate certificate, which is part of a master's degree or a full master's degree. And then they can probably do a graduate diploma. And we also offer the highest qualification, which is Doctor of Engineering. So there are multiple pathways. Either you could do year 12, year 12, and then bachelor's and master's and up to doctorate. So we got all possible pathways starting from diploma to year 12 to bachelor's, master's, and all the way to doctorate. So we can help you with your journey wherever you are in your currently. So let me talk about the very basic courses which we run is called professional certificate courses or professional certificate of competency courses. These courses are designed for people who like to upgrade their knowledge in a specific area in a short time. For example, all of these courses which you are seeing here are part of mechanical engineering, and they are only 3 months long. And in order to get the insights into, for example, gas turbines or hydraulics, pneumatics, or mechanical sealing, you can actually take up this 3 months course to get quick understanding of what goes on in that particular field, and you can probably consider it as a professional development if you are changing the company or if you like to upgrade yourself with certain knowledge. Yep, so usually anyone can enter these professional certificate courses, and entry requirements are not that strict at all. And if you are looking for more bigger commitment, obviously you can go for advanced diploma in mechanical engineering and advanced diploma of plant engineering. Now these are longer courses, means it will be for around uh, around 18 months total time, and this is the time commitment and attendance requirement and so on. So these are the two mechanical engineering advanced diplomas we have. And the next one we have is a typical example of an advanced diploma of mechanical engineering. So what would you study if you do advanced diploma of mechanical engineering, which is 18 months long course? It has got 21 modules. Now, it looks like 21 subjects. Yes, they are like 21 different subject areas, but these subjects aren't long, very, very long. You can see the first topic or first subject is only 2 weeks, then another one is 3 weeks, and all together within 18 months with some breaks, you can complete your advanced diploma. And it's very, very popular among the people, among the technicians, even the professional engineers working in the industry. Sometimes they like to, stay abreast of the technology. They do advanced diploma for promotion, for knowledge upgrade, or whatsoever. So that's advanced diploma. And now I'm going to talk about higher education courses. So anything above advanced diploma is coming under HE or higher education. So in higher education, we have an undergraduate courses. So it can be a simple 6-month undergraduate certificate course in mechanical or foundations, or you can actually do full 3 years degree. And you can actually take this 3 years degree in full-time mode if you are available, or if you are working and you got other commitments, you can do it in part-time as well. So you can do Bachelor of Science in Mechanical Engineering, which is a 3-year course fully online. It means, someone who is working on a remote mine site or oil rig, they can't come to a campus. So they usually, subscribe to the online course. But if you want to come here in Australia and study in Australia, you can actually join our on-campus course. It is the same course, but it's running on campus here in Perth. So, and then we have postgraduate courses like master's degree, which can be broken into a 6-month graduate certificate or a 1-year graduate diploma if you want. But if you want to do the full master's, it will be 2 years course, fully online again, and you could also join on campus over here. So that's about that. And finally, the highest qualification which we offer everyone is the Doctor of Engineering. So it's a 3-year full-time commitment or part-time equivalent, and it is also offered fully online or on campus. And you can see most of these courses starting in January. So that's an excellent course, very, very popular in professional engineers who would like to convert some of their ideas and industrial knowledge into a doctoral thesis. They are actually working towards them currently. Yeah, so next one is I'm very passionate about these on-campus programs because I am based in Perth in Western Australia, and we run these bachelor's programs, especially in Perth, but we also have 2 more campuses, one in Melbourne and one in Brisbane. So I'm going to talk about the undergraduate or bachelor's courses. So we got 4 bachelor's courses running. Obviously, in this particular session, you would be interested in mechanical engineering. So in Bachelor of Science in Mechanical Engineering, you can come and enroll into our Perth campus. We have got beautiful brand new campus here in Perth, and it's a beautiful city as well. So that's there. And if you want to do a master's degree, for example, if you already did a bachelor's, you don't want to do bachelor's anymore, you want to go upside. So you can actually take up Master of Engineering in Mechanical, and which is offered at 3 different campuses. Everyone, we can take it either Perth or at Melbourne or Brisbane. These are like 3 far distances, like far cities in Australia in 3 different points. You choose your location. And obviously the 4th location, which is fully online, is also available all the time. Yep. So those are our campus locations. And I would like to also let you know that EIT is a private engineering college, but the accreditation and recognition of our courses is on par with any university here in Australia or around the world. So we got a local government agency called TEXA. We got fully accredited courses. All of them are running. And also we got Engineers Australia recognition of most of our courses, either fully or provisionally. So that's the link you can click to see our accreditation for Engineers Australia and also obviously TEXA as well. Now let me talk about our course delivery model at EIT. So EIT is such a diverse engineering college. We have actually global pool of lecturers. We got 300 plus lecturers located all around the world, and our students are more than 1400. This number has gone up so much, and they are in from 160 plus countries. So almost like you name the country, if you know the name of the country, that's the country would have some students for EIT or studying under EIT. We have fully online learning for our online courses, which actually has synchronous and asynchronous portions. So asynchronous means you can study certain type of materials and videos on your own, but then you would also have the synchronous, which is live sessions with your live lecturers who are industry experts, and that makes EIT so unique compared to all other online providers. We also have online libraries and some virtual and remote labs. I'm going to talk about that in a minute. So let's go forward. And this map is actually showing you the locations of our EIT's lecturers. So you can see almost North America, South America, part of Europe, Africa, Middle East, India, Pakistan, Australia, New Zealand, and I think few more countries are also there. I might not have updated the map, but our lecturers are industry experts and really renowned people in the world. We don't just choose someone with some bookish knowledge. We would hire someone who really know their stuff. And when you are studying with them, you feel like there's a lot of energy coming, and you get the motivation to work like them in industry after studying with EIT. So that's there. And in terms of course delivery, so how do we run our online face-to-face classes? So online deliveries would be virtual, like your lecturer would be in front of you, like I am speaking at the moment, and you would be joining Big Blue Button, which is one of the big platform we have, on which you would have live interaction with your lecturer. You can turn your microphone on, you can talk to them, you can ask questions, and so on. So these are other platforms which we use, Moodle and Paradigm for enrollments and for materials. And let me talk about the remote and virtual labs which we have at EIT, because many times students wonder that if I'm doing an online course with EIT, how would I do my labs? How would I learn about softwares and practicals? So let me show you. So this picture is actually showing you that EIT has remote and virtual labs all across the world. I mean, it's virtually available everywhere, but we have got some servers in United Kingdom, South Africa, Western Australia, and it is all stored here. So we got really expensive softwares and practicals and laboratories stored on cloud. And through cloud, you can access them 24/7. Isn't it amazing? So let me show you a picture. For example, some of the equipment you can remotely operate and remotely do your experiments. So there are web cameras fitted with it, and you follow certain steps. You can, operate the mechanism, and you can take the test results, and you can write your lab reports. So the laboratories and virtual laboratories will not, deter you from, if you are sick on a day, you can't miss it, because even if you are anywhere in the world, 24/7, you can actually join these laboratories and do your experiments, and you can do it multiple times. You don't need to wait for one particular day or one particular time. So that's the beauty of EIT's remote and virtual labs. Okay, in terms of some of these virtual labs I'm talking about, mechanical engineering courses are equipped with industry grade software. So these are the software which are used in the industry, and it is actually taught by industry experts, not just by some random people. So here you can see all the names: AutoCAD, Inventor, SolidWorks, ANSYS, MATLAB. For gas turbines, which we use GasTurb, Python. Obviously, these are Microsoft products as well. So all of this, advanced software are actually being taught as a part of your course, whether you are doing a professional certificate, bachelor's, advanced diploma, or master's or doctorate. We ensure that high-tech, technologies, trending technologies, and also related software are all covered there. Okay, so these are a couple of examples in which I'm just showing you what your lecturers actually do in your live sessions with you. So in live session, for example, if you are learning about computer-aided design and manufacturing, you would be designing parts. Dr. Arti has showed, Dr. Arvin has also explained the type of technologies and branches we have. So all of these branches and technologies and software are actually taught live in your classroom, and you would be seeing that a lecturer, an industry lecturer, is actually streaming into your classroom from Canada or from America or from New Zealand or from Spain, teaching you the real stuff. So these are a few pictures showing you how they are teaching live interactive tutorials by showing you the software, how certain things are designed, and how certain cars or vehicles can be designed or pipelines can be installed. All of this is taught live in front of you. So with that, that's all from me, everyone. If you got any questions, feel free to let me know. I'm really, really excited to have you all here. And over to you, Barry. Thank you.
Thanks, Milind. Thanks, Arvin. Again, thanks, Arti. I think you gave a nice overview of mechanical engineering. So we'll just wait to see if we have a couple of questions. Feel free to make use of our chat box. You can paste some of the questions you might have to our lecturer. Anything technical or just generic questions, welcome.
I can see someone ask this question. Good luck Koka has asked, please could you explain more about differences between graduate certificate and graduate diploma? Okay, so graduate certificate is actually first one semester of your master's. So we got 2 years of master's. If you just complete the first semester, you can actually exit from the course with a graduate certificate, or you can enroll into graduate certificate, which is a 6 month of course, long course, and you can get that certificate. And 6 months later, you could say, okay, I want to actually continue my master's. So if you bring in your graduate certificate, you can get that credit and you can complete the rest of the 3 semesters and complete your master's. Similarly, graduate diploma is actually 1 year course. So it's basically first year of master's covered in graduate diploma. So if you want to exit at the end of your first year of your master's, you would get graduate diploma, or vice versa. If you want to do graduate diploma first to see how it goes, and then if you like to continue with master's, you can basically do it. So I hope that helps you with your question.
Okay, it seems as if there's no any questions that is coming by. However, I just want to reiterate to everyone that yeah, we've got most of our programs throughout the whole week. So I will just put also a link in the chat box so you can go to our YouTube channel. You can actually do sort of like a review of some of the topics or courses we've covered throughout the whole week. Just 2 questions came through. One is, what is the entrance criteria for diploma in mechanical engineering?
Okay, so entry criteria, Dr. Arti, if you could paste the link of advanced diploma, please. So we have advanced diploma in mechanical engineering, but usually, Ernest, we actually need couple of years of experience in advanced diploma. So you should be working in the industry, in mechanical type of industry for some time before you can apply for advanced diploma, as far as I know. But if you are not meeting the entry requirement of advanced diploma directly, what you could possibly do is you can enroll into a professional certificate of mechanical engineering. And by that pathway, you would have some exposure to mechanical engineering, and then you can try for advanced diploma. So there is always a pathway connected with advanced diploma, because advanced diploma is usually requires some experience. So here is the link which Dr. Arti has pasted in the chat box. Yep.
Thanks, Milind. And I'll just cover the second one. So we have educational partners in Nigeria that assist students with the application process. more especially students who are interested to study with us on campus. So we do have educational agents or partners in Nigeria. I will just share my details with you. So should you have maybe some interest in studying with us on campus, please send me your details. I'll be happy to assist you.
Also, I can see Amina has her hand up. So is it possible for her or him to actually open the mic and talk?
I don't think we'll allow people to actually speak, but
Yeah.
they can paste their question in the chat for now.
So Amina, can you please, type your question in the chat box? Oh, yes, I have a question. I'm based in South Africa with a Bachelor of Technology in Mechanical Engineering and interested in doing Master of Engineering. Are there any opportunities for scholarships? Yes, we have plenty of scholarships on our website. And I think I can ask one of our colleagues to actually paste the link for the scholarships. And here you go, Dr. Arti. Thank you very much. So she has actually shared the link of the scholarship. So just go through all of these links and see where you can qualify for a scholarship. Yep. Good luck. I look forward to seeing you in teaching mechanical engineering masters because I'm one of the lecturer as well. And Dr. Arvin and Dr. Arti are also lecturers.
Dr. Milind, I'm not sure you have seen this one. As a civil engineer student, what are some of the mechanical software that a structural engineer can use?
Okay. I just saw this. Yeah. Some of the mechanical engineering software a structural engineer can use. Yes, AutoCAD is one of them. AutoCAD and ANSYS, those are the two software which you could use in structural engineering. Yes, Dr. Arti said AutoCAD is a very versatile software. She herself is a trainer, a lecturer for all the CAD related software. So yes, he just confirmed what I said. AutoCAD and ANSYS are very good software. I hope that helps, Amina.
Anyone? Okay, I guess we can just leave it here for now. I'm not sure if you want to say a few comments, Dr. Arti, Milind, Aravin.
I don't have any further comment.
Yeah, nothing from me also, Barry.
Yeah, same here. Nothing from my end, but good luck, everyone. And I hope this session made some sense and it gave you some more information that you're looking for in terms of mechanical engineering and its various different applications, trending topics, and courses we run here at EIT. Thank you, everyone.
Okay. Thanks again to my team, and thanks again to all the audience, and we shall see you soon. All the best. Thanks.
Thank you, Barry, for your support. And Lee, catch you later, guys.
Thank you, Barry, and thank you, everyone.
Thanks, Barry. See ya.